All right. So sorry about that technical problem. OBS is always a treat to work with. Sarcasm, of course. And I'm just going to post that the stream is live. And we'll hit the road. We're now live. Sweet. So I want to greet everyone, and again, I really appreciate everyone's time, so thanks for waiting. My name is Morgan, and I'm with the team at Decentology, and we're hosting these Flow Developer Hours every day, almost every day, for the Mercury Hackathon. And during these hours, hey Danny, thanks for joining. And during these hours, we learn about things like contract development, but most importantly, integrating it all into a single working app. Hey Justin, hey Hardik, really nice to have you. So the point is to build decentralized apps, or dApps. And decentralized apps have two major components. One of them is the use of a blockchain in a decentralized way. And another one is the client, or the front-facing, or the client side. Hey Amethyst, hey Brainchild, it's really nice to have you guys. So one can't work without the other. Technically, you could just interface with straight-up developers that use command line interfaces and allow them to interact with your contract. And in the beginning, that's all that we had. But since we want to move people onto the Web3 ecosystem, we want to make it as friendly as possible. We need to go the extra mile and work on our user interfaces. We need to integrate well with the blockchain, and as such, these Flow Developer Hours are also focused on the client side. Now, the assumption is that we're working with React and Flow. These might not be your primary choices for your tech stack, but they're pretty popular, and given the emphasis of this hackathon, Flow is a must-have. And React, well, it's an opinionated choice, but it's a pretty popular one, and we're not overbearing with the amount of extra libraries that we add. We sort of work with the baseline vanilla stuff. All right, so having said that, let's get going with our screencast and start exploring things as they are. So we have our baseline contract, which is the awesome Nifty that we're working on. The contract you can see right here on Flow View Source. Hey Akulash, thanks for joining. So I'm sharing things on YouTube and on Slack for you guys to follow afterwards. And we're working with this repository that's on YouTube. It's a public repository. Zoom it, please. All right, let's zoom in a little bit. Okay. So everything's zoomed in, I believe. All right. So we're working with this contract. We're updating it a little bit, and we want to interact with Flow Nifties here. Okay. So we're gonna iterate a little bit on where we started or where we left off. Hey Sumaya. And right now I'm just gonna walk you through the basic functionality. All right, Danny, thanks for confirming that. Brainchild as well. So we have this list of accounts. This is the Minter account. Hey, Hui. Love to have you here. Really appreciate joining. So we have this Minter account that created this contract. You can see it over here. It's the same address. And as such, during the init phase of the contract, we created a minter and stored it with the account that created this contract, deployed this contract. And we have a collection of nifties, of awesome nifties, and they really map a string to a unsigned integer contract. So that's the baseline functionality here, but we're wrapping it up in a nice client to make sure that it's something that we can publish to users. And maybe for next week, we're going to have a domain where this lives live, and we get, we can interact with what's on the contract without having to run this locally. But the point is for you guys to be able to follow me is to deploy this, pull this repository locally, clone it, and then npm I, npm yarn start to be able to interact. Okay, so I spoke about these collections and about these nifties. So I'm gonna mint one and then send one, do a transaction between these. So let's mint a Friday awesome nifty. And we have this status field here showing its progress. Go ahead and approve that. And now we see it's submitted, and it's going to cycle through executed and sealed. Sealed is the final stage of a transaction. And now we should see number 16 Friday here. All right, so now I want to send Friday here to my other account. So I'm going to provide the ID, which is 16, and send it there. Okay. So any kind of transaction, we have to approve it with our block the wallet, and we'll see it come through. Status submitted, executed. So that means we didn't have any errors in our transaction and we got sealed. All right. Snap happens because this is a yarn start, and this new version of Chrome sometimes has a hic. Cool. So Friday. So Smita, hey, thanks for joining. So we have Friday in the other contract. This happens to be my other account. And let me see. I'll try and transfer it back. So I have, you know what? I'll transfer 13 back. So pay attention. 13 is with this account, the A3BD. I'm going to approve a transaction. This is on my other screen. And once that transaction is completed, we should be able to see it in this account. Okay, so refreshing, boom. So sharing is back as number 13 right here. Hey, wait, how about we send duplicate when what happens? Well, we can't really produce a duplicate since nifties are stored as a dictionary. This version of Chromium is super buggy. So when we're storing these nifties in collections, we are getting the identifier from the minter. Okay, so there's a total supply counter, and we set the ID. We increment it, and every mint just increments the total supply. Total supply is never decremented, so even if we somehow were to destroy a nifty, we'd always get a new ID, and if anything, we'd have a missing slot, but that's about it. And inside of our collections, nifties are stored inside of a dictionary that points UN64s, which is the minty ID, nifty ID, and it points to an NFT. So there shouldn't be any duplicates. Akhilesh is asking, can't we do something that the smart contract don't ask us to approve the transaction? Well, we're already doing things that don't require anything. So for example, all of this, us pulling in the data for what's inside of our collection, is interacting with the contract. but it's a script. It's a read-only thing that we do, and read-only things do not require signatures. Things that let's increment the size for the source code. Sorry, Mayrab, just noticed it. Yeah, reading doesn't require authorization. Writing, changing, mutating the state requires authorization, and for a good reason. Storage is held with accounts, and accounts need private key authorization. Okay, so we kind of reviewed this a little bit, and we have this list of commands, we have this list of accounts, and it's kind of hard to keep track of who's got a nifty collection, right? So we want to do something about that. We want to maintain a list, perhaps on the contract account that we'd be able to query when someone creates a collection. Okay, so let's say that we're gonna create a new version of this. Okay, so let's call this awesome nifty. You know, for simplicity's sake, I'm wondering if awesome might have outlived its life. Let's call this nifty CDC. That could be a simplification here. So what do we want? The difference here is you might see there's two events that we didn't have previously, and we're going to add a couple more for when collections are created. Okay, so there's another thing that we want to do. We have this minter thing, okay? And when we mint, we sort of interact with the storage. But, and let me collapse these to make this more legible. Okay, so we have this basic structure here. We have an NFT resource, a receiver interface, a collection resource, and a minter resource. We want to add another resource that will be sort of like a list of everyone that has a collection. Okay, so let's call this pub resource ledger, and this is going to be just a simple ledger resource. Okay, so what is it gonna have as its structure? Well, we're gonna have a field that's gonna map address, or maybe just an array. You know what? An address to strings, so that maybe later down the line we can add like a nickname or something. So let's call this collectors. And collectors is going to be, since we're interacting with a collection, so collectors is going to be a resource. Let me think. Should this be a resource? Maybe it's just a structure. So yeah, so this is just a simple dictionary. So it's going to be address points to a string. Okay, so it's screaming that we have an uninitialized field. So we're going to have to create an initializer, and we initialize collectors to an empty dictionary. Okay, so now we want to be able to add to this, and let's see here. So every collector creates a collection. So when creating a collection, we call it with, let me think. this is this is an interesting point, because when we generate a collection, we call this contract function, right? And this contract function can probably accept like collector as a field, and right here we would do like a self dot okay, so we might as well do that. We can interact with the reference, so let's go ahead and create a reference here real quick. Let's see. So we have to save ledger self account dot save. Oh boy. And here dies the Cadence language server. So we're going to save create ledger, and we're going to save it to /storage, and this is going to be nifty ledger. Okay, and we're going to rename these so that we're not mixing things up. So this is like an evolution of our initial contract. Okay, so this is now complaining. It's expecting another argument for the collector field, and that will be self.account.address. Crashed again. So self.account.address just points to the account that is deploying this contract, and we just need to be able to identify who's calling that specific function. So at this point, we have our nifty collection stored in storage, and now we want to link to it. So we don't want to load it back from our storage, and because then if it's loaded, we might run into a problem where we call that function again, and a prior transaction hasn't stored the collection back, and then we might run into an issue. So to avoid that, we're gonna create a link or a capability, and for now we're just gonna make that a ledger reference. Okay, so ledger reference is going to take this public, oh, it's not nifty, it's right here. Okay, so this is public nifty ledger, and the target is storage nifty ledger. Okay, so we have a link, and now at this point, when we're creating a collection, we can go ahead and do self.account.load. Not load. We need, just one moment, bear with me. We're going to open up the documentation for reference so that I'm not misleading you guys. Okay, so we are going to reference self.account, and then we're going to fetch the capability, and that's going to be /public/nifty ledger. Okay, and then we're going to borrow it. Okay, and the type will be reference to ledger. So this is ledger, and let's create a function. your cadence. So Mayrab is saying that his cadence server died a couple months ago. Yeah, those things are fragile. So a rip to your cadence server. It's one of those problems with any kind of new software. All right, so we want to add a collector, and that collector is going to be an address, and then an optional, let's call this identifier, which is an optional string. Okay, so we're going to do self.collectors, and let's take a look at the docs. It's always a good thing. Let's look at the cadence, language reference, values and types. And what are we looking for? We're looking for dictionaries. So we want to make sure that that address doesn't exist. Here we go. So this has contains key. So let's call if ledger contains key collector. Then we're good to go, and we're going to call the add collector with oh, you know what, maybe we should implement this so that it's like a single interface. So pub fun has collector, and then we're just going to send the address, and this is going to return a bool, and literally we just self.collectors.contains key and the address. Okay, so we're just going to call, we're implementing like this little tiny function just to unify this interface that we have. So we have this ledger, and we're going to check for if it has a collector. Okay. If it doesn't, then it's going to add the collector. Okay. So this little thing, this underscore, it's going to not require the label, because we're kind of, passing this thing as an address already. So, that's, we should be good there. Now, when we're adding a collector, we want to be specific. So address is going to be collector, and identifier is going to, let's skip this part for now, because when we're adding, it's unlikely that we'll ever deal with an identifier. Okay, so add collector. So this is going to do, we're going to, that's helpful. So let's see, we want to work with keys. All right, so contains key, values, keys, remove, insert. Okay, inserts the given value of type V into the dictionary under the given key. Okay, so we're going to do collectors insert, and this takes a key. So that's going to be address, and then value is going to be nil. Okay, so now we're adding collectors, we're checking for collectors, and that seems to be good. Now we need the ability to get our collectors back. So pub fun list collectors, and this is going to return a dictionary of address to string key value pairs, and we're going to return self.collectors and be done with that. So list collectors, add collector, has collector. And now this ledger thing, I believe, to be ready. Okay. So we have, just making sure, quick collector. All right. Let's add another event. Pub event collection created for dress. Okay. So take that and we're going to emit it when we create a collection. All right, let's try and deploy this. So we're gonna use flow view source for our contract deployment. And while I'm setting this up, so this is the contract. We're gonna call this Nifty, and we're gonna deploy it. While it's deploying, let's read the chat. So Amethyst is saying, or is asking, can you explain the question mark after string in add collector fun? It's a really good question. Okay, so when we take a look at this add collector, and there was an identifier string. So what this string means is we have an optional value. And an optional value in Cadence, that just means that there might be that value, or we might have an absence of a value. And this, since this is a critical concept to understand, I'm gonna try and run through a few examples. So let's see here. Let's optionals.cdc. All right. So we're gonna do pub fun main, and we're gonna try and log test just to make sure that I can still run it. So flow, cadence, and then optional cdc. All right. So we got this testing. Cool. So here's a quick explanation of optionals. So let's say we have a name. All right. So if that name is of type string, Stu Morgan, well, when we print name, we're going to have, a simple string. But let's say we turn this into an optional. Okay. Then whenever we interact with this value, we can either have a string or expected transfer. Oh my Lord. All right. We might have a presence of a value or nil. Okay. So if, let's say, name is unset at the moment, it's initialized with nil, and then we log name, then we get nil. But then we can set this to Morgan and log name again, and let's see what we get. We get nil, and then we get Morgan. So once we set name to a specific value of a string, then it's got a string, but we never know for a fact if it actually does. So let's see if we can work with this. So for example, what if we did name.length? Okay. Well, we get this error right here that says value of type string is no member length. Okay. Well, that's because at this point, line number 3, we're not sure if name is has a value or if it doesn't. Okay. We could make sure that it does have a value if we did an if statement. So if name is not equal to nil, and we put everything in this if block right here, then we should be able to run this. Oh, we're not able to run this because we're still using the same syntax. So in this case, well, we know that name is not nil, so we can go ahead and use this exclamation mark to denote that we're 100% sure that name has a string value. Okay, so with that, we should be able to log this. Let's set name to something. Okay, so length is 6, and we're good. Now, the exclamation mark is for the times when either we're 100% certain that this optional will have a value because we set it, like on line number 3, or we depend on the optional value, and if there's no value assigned to the optional, we might as well scrap the entire transaction. We want for the transaction to fail. Well, in that case, we can also use an exclamation mark. But if our logic, so without the question mark, we get an error because length is not defined for an optional. So in cases where our script can work with and without an optional, so like let's say we have if name is nil, we do something else, we do something else. So if name is nil, then we log name is nil. But if name is not nil, then we log name exclamation mark dot length. Okay, so in this case, we're going to have length printed on the screen, and if we comment this line out, then we're going to have name is nil. All right, so this is where we're accounting for an optional. Now let's say we're not particularly interested in whether the value is assigned or not. Maybe we're just printing, or maybe we're passing it along. Well, we can go ahead and do this. Name question mark dot length. Okay, so in this case, it's gonna print nil, but if there is a value assigned, then it's gonna carry on and call length. So this is kind of a nice interaction where with an optional value, we can have variables and constants that may be empty or may have a lack of a value. And if there is a lack of a value, then we can sort of operate on the nil pattern. If we're sure that there's a value, we can use the exclamation mark to get at the value. Or if we're unsure and we don't really care, then we can use a question mark, which will only proceed if the value is not nil, and will stop if the value is nil. And on top of this, we can chain these things. Let's say length was an optional thing too. We could do length and then something else. Okay, so we can create a long chain that we sort of, here, I'll give you an example. So let's say there's a person struct, and it has a public name that is an optional string. And then we have an init name string, not strong, but we're strong as a community. And we're going to do self.name equals name. All right. So let's say we have a person. So var Morgan equals person, and then we call this with Morgan. Let's go ahead and log that. By the way, I really love this question, Amethyst. This is, means that you're listening. Is a strong question. All right, so we have this optional person thing, right? But let's say we want to see what's the length of the name Morgan in this person. So we can do an optional. All right, so we have Morgan, and then we can have a var person, which is an optional person, and that's nil. So, let's bring this back to our collector analogy. So let's say we have a collector, maybe we have a collector, maybe we don't, we're not sure. So we want to see what's the collector's name, all right? So we're going to string this collector, then we're going to do name. Now, if the collector has identified himself with the name, then we can check for length, okay? So this is not going to fail. This is going to print nil because collector is not defined, all right? And I'm going to set this to nil just to kick this off. So let's say we define collector as Morgan. That still gives us nil, all right? Because even though we move past the collector to name, name is nil because we set it to nil. If I do Morgan, then we should have a length printed, okay? So this prints 6 because the collector is defined, the name is defined, and so we can get back to the value. Hopefully this is a good example for you, Amethyst. Let me know if that helped. All right, so there's another question from Akulash. Can't we write test in JavaScript for testing over smart contract before deploying them so that we can ensure that it is functioning as we want? You're correct in the assumption that we need to test things, and those tests do occur. So we have the test net. So that's sort of a secondary stage, kind of like a staging environment where we replicate all the functionality of the mainnet. But we also have the emulator. Okay, so an emulator is something that we can launch by doing flow emulator start. Okay, and now if we point our Fcl, let's see here. If we point our Fcl, which we initialize in the app, right? If we point this to the emulator, well, then at that point, we'll be interacting with the emulator, and the emulator, we can submit tons and tons of unit tests. And that's something that we're definitely going to cover in Flow Developer Hours, maybe not next week, but the week after, which, this is something that you do towards the very end of your development cycle. But you're right, Akalash, we do have this thing where we have an emulator, we have a local unit test environment, and we run through these things to make sure that everything's fine, and only then deploy to the mainnet. And there's people working at Flow that make sure that every contract that's deployed passes all the tests that are required. Okay. So Brainchild47 has a final question. If you run this code without the question mark, then what will happen? Well, we're going to see an error. So let's say we don't assign Morgan to person, and we just do .name.length. Let's clear this up, and there you go. So it says that this person optional does not have a member name, and it points us to where we failed in our source code. So line 11, unknown member. Okay, line 11, name is unknown because this can be an optional. To read more about optionals, I would suggest going to this beautiful documentation, and right here we have optionals. Okay, I'm going to link this in the chat and on YouTube as well. Sweet. Love the questions. This is great engagement. Mevrab is asking on Slack, can we use Mocha and Chai for testing? Absolutely. The thing is, we're interacting with the JavaScript framework, which is Fcl. And Fcl can hook into any unit test framework. I'm personally using Jest, which is the test framework that's team with React have worked on. So Jest is something I do. But there's obviously Mocha, Tri-Select, tons of other frameworks, and we're integrating into them using Fcl. And yeah, should be pretty easy to do that. Thanks for that question. All right, so love the engagement. Keep them coming. Whenever you have questions, I'm here to help you out. This is a collaborative effort. Cool. So let's close this up and let's go back to our nifty contract. Let's see if it was deployed. I wonder. Let's reload this page and make sure. Ooh, it only has one contract. Something went wrong. Let's redeploy. Okay, deploy contract. Akhilesh is asking, I just want to ask, is memory not assigned to the variable if we write question mark? You'll have to specify your question. Is memory not assigned to the variable? Oh, we have an error. And if assigned, then what does it contain? When working with optionals, nil is still, it marks an absence of any value. So you can view this as it has nothing there. So there's nothing in the memory. It's a clear, empty box. You still have that box, right? But it's empty. Huey is asking, can Fcl work with React Native? Yeah, I believe it can work. It's something that I haven't tested, but it works on the principle of an iframe, and I believe React Native has no problem rendering iframes. This is a great question. This is something that we're probably going to get back to since mobile development is very important. So thanks for that. I'm gonna take a note actually to look into that afterwards. Okay. Just one moment. Yeah, React Native is a big platform, and we want to be able to support it. All right, Akhilesh, hopefully I answered your question. Now let's get back to fixing this thing. So cannot deploy invalid contract. Nifty ledger has no member, has collector. Okay. Oh, it's a question mark. All right. So when we're borrowing a capability, we're not sure 100%, but at this point, we link this up first before we create a collection. So we should always have that available. So that should be fine. Insert. Where do we have that? Okay, yeah, address. Oh, address. Add collector. Expected. Got never. String mismatch of types. So ledger add collector. That should be fine. I think that single update with an optional was the thing that was breaking this. So let's redeploy this. All right, Akhilesh says, thank you. Thanks, man, for getting back to me. Yeah, happy to help. So we're redeploying this nifty contract. And we did have some errors. We have some more errors. Mismatch type collectors, insert nil, expected string got never. Oh, okay. Well, we're declaring a string. We need an optional string here, actually. So we're just gonna change that to be nil or an optional, and copy this again and redeploy it. All right. Third time should be the charm. Submit it to chain. So this is a nice interface. Like I said last time, Oh, it's got executed. That means no issues with the source code, and we're waiting to be sealed. We got it sealed, and boom. So we have Nifty inside of our contracts list. Okay. So now let's see if a couple of things happened. So this account, this main account, should have a collection present, but all the other ones shouldn't. Okay. So let's update our account code to now look for, let's replace awesome Nifty with Nifty. Okay. Across 3 files. You know what? Let's replace it locally. So we're looking for awesome Nifty, and we're going to replace each one with Nifty. Boom, boom. That's fine. This one is Nifty. So we want a case specific. So replace that, and that's good. So now, awesome Nifty. Okay. So let's replace that with Nifty. So account should be good. All right. So see how quickly that updated? That's a win in my book. We have a collection, but it is empty. But we should have a list of accounts in the ledger. Okay. So let's write a script that, let's see here. So we have a list of accounts that's deprecated, and let's see if that breaks anything. Line 45. Line 45. Okay, let's hard code it to my account. That should be good. Okay. So in here, we should start with an empty list. Okay. And we need to pull this live from, you know what? We're going to have a script. So check collection is something that we're going to replicate. We're going to do fetch collectors. And we're going to use callback, which is a React hook. And it takes a function. So that function is going to check for all addresses. Okay. So what are we looking for? We're looking for the ledger. And that's going to come through fcl.send. Okay. And let's do the then part so that we don't forget it. Decode. And we can execute a script by calling fcl.script and providing the template and some arguments, but we don't have any arguments in this ledger right here. Okay. So then let's proceed with the import statements because we're interacting with Nifty contract since we renamed it. So let's make sure we rename everything. So boom, boom, boom. Okay. Now let's rename awesome Nifty with Nifty. Okay, replace that. Okay. That should do it. Hopefully it didn't break anything. Yep, we're fine. What else? Well, let's see. We updated this. We checked the collection. We checked fetch the collection. Fetch the collectors. All right, that's where we left off. So we got to import our contract. So we're importing Nifty from this account right here, and we have a pub fun main. It doesn't have a body specifically, and it's going to return a collection of addresses that point to optional strings, right? In fact, yeah, that's what we need. Okay, so what are we doing? Well, we're going to the ledger reference that exists with our account. Okay, and we're getting a capability that's with public dash nifty ledger. Let's make sure that that's how we stored it. Nifty ledger, public nifty ledger. All right, so that's what we're referencing. So we're getting that capability, and we're borrowing that capability. We just need to provide the type that's expected, and the expected type is a nifty ledger. At that point, we can go ahead and return the list of collectors. Okay, so here we should console log this and see if we get what we expect. Let's see. So we get, oh, we need to actually call this. Classic mistake. All right, so on send, we're gonna minimize these, and we're gonna use an effect for this. An effect is another hook with React, and fetch collectors to see. Okay, so this thankfully does return something that we expected, and this dictionary has an address pointing to null. Okay, so let's see if we can create a collection. So I'm gonna log into my other account, and I'm gonna try and create a collection, which would then allow me to list 2 addresses in there. And at that point, we're kind of safe to say that this works. Okay, so let's wait and see until we can confirm. It's taking a little longer. No problemo. And what do we get? We have a transaction ID. We can inspect it on testnet flow scan. So it's finalized. What does that mean? Execution pending. Okay. While we're waiting, Akilesh is asking, what if we wanted to fetch the collectors which not present, or the address of the collector is not over smart contract? Well, I'm not sure if I understood your question fully. If the collector was not added, execution failure, invalid proposal key. Okay. All right, so something went wrong. Let me try and redo this. Create another collection. This was a wallet related error. And I don't know, maybe because Chrome crashed or something. That happens. So we have another transaction ID. Let us look that up. Oh, okay. We need to update our create collection part, and that's with account, I believe. Check collection. no, that's with page, right? So when we have this button, create collection, goes here, and all right, so we're creating the collection, and that needs a collector address. So we forgot to include that. So that is going to be with account.address. And so this is an authorized account address, and we're going to be pretty sure that this will work now. All right, creating another collection. We're trying to create a collection for this one final time. Let's see. We have another transaction ID. Okay. So this was sealed. And this seems to be working. Let's see in our Hopium thing here. Boom. So we have a dictionary with a list of 2 collectors. XYZ admin. Hey, sorry, I missed your greeting. So we have a working collectors ledger that will then enable us to use it inside of our accounts list. And that way our accounts list will no longer be hard coded. And for next week, we'll be able to play around with that concept, maybe add nicknames, and maybe even publish a alpha build of this thing online so that anyone that's viewing can play around while we work on these things live. So that's the goal, and we're sort of going towards it with this ledger concept of all the collectors. All right. So one last question Akhilesh is asking, what if we pass the address that is not present? Okay, so here's the thing. In this transaction here, we're not directly passing in any arguments. You can see the arguments array is empty. And the only place where we interact with an account address is this. Okay, so account in the prepare statement points to the account that's authorizing this transaction. Okay, so you can't really fake that. You can't really pass that. And so we can safely say that whatever we pass along to this collector argument, which is the account.address, is the actual account address that's authorizing this transaction. So in that case, we're perfectly fine with what we're doing. There are other instances where that might not be the case, where we're sending arguments, but when we're authorizing, then that can't be fooled per se. All right. So to finish off today, really appreciate all the questions. This was probably the most you guys have ever asked. So it's a pleasure for me and anyone that's contributing to this hackathon to see you guys contribute and ask questions. We did explore an update to our awesome Nifty contract. We renamed it to nifty.cdc, and we added a ledger resource that maintains a list of all the collectors that have created collections for our Nifty storage. And we'll transition over to using that next week. All right, so for now, this concludes our developer hours for October 8th. We're going to have a bunch of presentations tomorrow with Mercury, Build with Mercury sessions. Jacob's doing one on Dap Starter and NFT plus IPFS storage. So make sure you tune into that. It's going to be interesting, and you guys can learn a lot. But yeah, this concludes developer hours for week 3. Week 4 is going to have a ton of cool stuff that we're building on constantly. I can't wait to see you then. But for now, from me, Morgan, and the rest of the team at Decentology, I want to say thanks and goodbye. Till the next one.